Back everybody. So we're going to look at another exam question, and I've already pre-made some answers and stuff, so I'm going to try to move a bit quicker in this one. So in respect of an investment project, define the discounted payback period. Well, that's really just it's really the net present value of the revenue covering the net present value of the outgoings or expenses, and how long that's going to take until that happens. And then the payback period is just when the net revenue covers the net expenses. It is really exactly what it is. So discuss why both the discounted payback period and the payback period are inferior measures compared with the net present value for determining whether to proceed with an investment project. So, well, the payback period, that's just going to tell you when the amount of money that you've got, that you've received, has covered the amount of money that you've paid, just in completely nominal terms. It's not at all going to take into account interest. Discounted payback period is going to take into account interest and will tell you when your project has started to actually make a bit of money. But it is possible to have a positive payback period while having, well, actually, sorry, well, in this case, it's just going to be that it won't really tell you how much you're going to be making, but it's just going to tell you when you've finally made some money, which may not always be useful. So let's look at part 3. A consortium of investors is considering bidding to host a major athletics event. The project will be regarded as viable if it provides a positive net present value at a rate of interest of 10% per annum, and that's the effective rate. Sorry, here's the pen. 10% per annum. The consortium estimates the following cash flows will be generated by the event, and all figures are in hundreds of millions, which make things kind of easy. So, all right, we got the initial cost of the building. It's going to be incurred continuously. Sorry about that. That one just keeps popping up. Continuously at a rate of 1 per annum for 5 years, and that's going to be starting on the 1st of January 2006. But in actual fact, we see that the bid for the event is in 2004, so we're going to have to discount that back 2 years. Then we've got the running cost of the event. It's going to be incurred continuously at a rate of 1 per annum, and that's for 3 months, starting on the 1st of January 2011. And the interesting thing is when we're looking at continuously and it's going to be less than a year, then we're going to be doing things a bit differently than just a regular annuity. I mean, it's still going to be a continuous annuity, but we're just going to be doing a slightly different calculation. Point 2 is going to be incurred on the 1st of January 2004. And now in terms of revenue, we're going to be selling TV rights. That's going to be received continuously at a rate of 0.3 per annum for 3 months. And that's going to be starting on the 1st of Jan 2011, so it's very similar to this one. And then we've got some other revenue, which is a whole lot of other stuff, and it's assumed to be received in the middle of each year. And it's going to go from 2004 when we start to 2015 inclusive, and it's going to start at 0.1 per annum, and it's going to increase by 0.1 up to and including 2011. Then it's going to be the same in 2012, and then after 2012 it's going to go down to 0.2 per annum until the middle of 2015, and then there's not going to be any more revenue from that source of revenue. And lastly, we're going to sell it on the 1st of January 2015. So when we're selling it, it wants to know how much do we need to sell it for in order to have this project viable, in order to get a positive net present value. Alright, so I thought it would probably be easier, instead of trying to write a whole lot of stuff down, is to use an Excel spreadsheet and just show you the calculations that's been done there. So I'm going to jump backwards and forwards. So let's start with this bit, the initial costs of building. So looking over here, I first worked out what I is, just 1 plus I. This is V, 1 divided by 1 plus I. D is 1 minus V, or I divided by 1 plus I. Delta, the natural log of 1 plus I. And this bit I'll come to in a second. And let's look at our expenses. The building expense. What did it want us to do? It wanted us to do a continuous annuity with just doing 1 per annum. And it's going to go for 5 years, so N is 5, and it's going to start on the 1st of January 2006. And because it's starting there, if we're going to discount it back to this point, we still have to go back 2 years. So we're going to be multiplying by V to the power of 2. And then it's just a regular continuous annuity. So over here we have 1 minus V to the power of 5 divided by, and that's delta there. And then we're just multiplying the whole thing by V to the power of 2. And that's really it. Then we're looking at the running costs of the event. So it said that it's going to be incurred continuously at a rate of 1 per annum for 3 months, starting on the 1st of January 2011. Now, when we're doing something continuously, what we're going to be doing is we're going to be taking e to the negative delta t, or yeah, we'll just do delta t in this case. So in this case, we're doing e to the negative delta multiplied by, and it's going to be 3 months, 3 in a year is a quarter times 0.25. And that bit over here is going to be our, instead of taking v to the power of a quarter, we're doing e to the power of a quarter, and the and delta up there. So looking over here, we have 1 minus and then C5. Okay, so let's have a look at what C5 is. And this bit is the exponential of negative delta over here, B5, times a quarter. So then over here, looking here, so we have 1 minus e to the negative delta times a quarter divided by delta, because it is a continuous annuity. And then we're just multiplying that by v to the power of 7. And so because this was worked out in 2000, when did the running cost happen? 2011. So over here we've got to go back 7 years. 1, 2, 3, 4, 5, 6, 7 years. There you go. And then it says the cost of making a bid, which is just 0.2, which is on the start date. So there's no discounting back here, it's 0.2. And when we sum it all up, we get 3.600 million. Okay, now let's look at the revenue. So this is the sale of the TV rights. It's going to be received continuously, 0.3 per annum for 3 months, starting on the 1st of January 2011. Okay, so that's going to be discounted back 7 years, as we did in this one. It's going to be that continuous annuity, but which is less than a year, so it'll be very similar to what we did in that previous one. So we have 0.3 multiplied by 1 minus, instead of v to the n, we're just doing e to the negative delta to the multiplied by a quarter of a year, all divided by delta because it's continuous annuity, multiplied by v to the power of 7. Then we're looking at the other expenses. Now this one's a bit complicated, so I've actually, this bit over here has summed up a whole lot of years, because this is an increasing annuity, and then this one's just a whole lot of extra payments, which can be simplified a bit, but I just wanted to go one after the other. So what did it say? It says that from 2004, in the middle of the year, we're going to be going 0.1 in the middle of each year, and it's going to go up by 0.1 up to and including 2011, which so happens to be, if we're starting here in the middle of 2004, 1 year, 2, 3, 4, 5, 6, 7, 8 years. Okay, so that's what we're doing, 8 years up to this point. So in fact, here's where we are, and I'll just leave a mark there so we can remember to come back to that. So how we do that is just a regular increasing annuity multiplied by 0.1, and then we could just discount it back. We just then discount it back half a year. So how do we find an increasing annuity? Well, that is just an annuity due minus NVN divided by I. So there's a whole lot of brackets in this one. Looks a little complicated. We've got 0.1, which is what we're starting with, and I've got 1 minus, and then I've got V over here to the power of 8 divided by D. And that's how we work out our annuity due over 8 years. And then I'm minusing NVN, so in this case n is 8, times V to the power of n, which is 8. And then that whole thing is divided by I, which is B1, which is just a regular annuity. So this over here, this whole bit, is an increasing annuity. And then we're just discounting that back half a year, so times B2 to the half. Sorry, we're not discounting it back half a year, that was my mistake. I think I made that one a bit earlier. In actual fact, what we've got to do is we've got to put it ahead half a year, because we've got to, what I've done is when we're multiplying it, we're doing it by 8 years. So in actual fact, what I did was I brought it back a little bit before the time when we'd started. So this is actually looking in the halfway through 2003 mark, so that's why I had to multiply it back in this one over here. And then we're multiplying it by 0.1. So that's this figure over here of 2.24. And then it says in 2012, so at this point in time, we got the same amount. So if we start here, we're getting 0.1, 0.2, 3, 4, 5, 6, 7, 8 over here, so this is 0.8. This one's also 0.8, and instead of discounting it back, how many years did we do? Instead of discounting it back, which was really 7.5 years overall, we, because that was discounted back 8 years over here, and then half a year we went forwards, this is going to discount it back 8.5 years over here. 0.8, discounted back 8.5 years. And then it goes down by 0.2 each year. 0.6, 9.5 years. And then we got 0.4, 10.5 years, with lastly, and that's 0.2, 11.5 years. So then I just summed it all up, and then I totaled these two, 1 and 2, and so now we've got our expenses against our revenue. So in this case, what it's going to be looking like is we have our expenses, and that's going to be equal to our revenue plus the sale of the TV. And the sale of the TV, let's call it X, we have to then discount that back. How many years? It's going to go back 11 years. So V11. And now we can just do our expenses minus revenue and then divide all that by V11, and that'll give us X, which is the sale of the TV, which is what it wants us to find out. So, here we go, it's already done. So here we have our expenses minus our revenue is whatever number that is. It's going to be like, instead of 100 million, $50 million, and then we have that divided by V to the power of 11 years, and that's going to give us this figure over here, keeping in mind that all figures are in hundreds of millions of dollars. So if we wanted to work that one out, we can take that bit there, we can multiply by 100 million, which gives us this bit over here, which might look a bit better. We can just see 149 million, and it just depends on how you've rounded as to how accurate you're going to be getting it over here. I'd say it's about $149 million, or million pounds. So we're doing 149 million, roughly. And that's how it's worked out. And if you've got any questions on any of that, just send a message and I'll be happy to explain it.